位嘉宾，欢迎回到 Computex Forum。今日议程，我们将重点聚焦于生成式 AI 与智慧内容应用、资料智能治理与安全、产业落地 AI 应用和 AI 运算基础架构与开发。Ladies and gentlemen, welcome back to the Computex Forum. Today, our sessions will focus on generative AI and intelligent content applications, data intelligence, governance and security, applied AI for industry transformation, and AI compute, infrastructure and development.
我们非常荣幸邀请到首位演讲嘉宾 Google Deepmind 季怀新博士。季怀新博士将为我们带来题为“个人化通用助理的未来”的精彩分享。It is our great honor to welcome our first speaker, Dr. Ji, VP, Research at Google Deepmind. Dr. Ji will share his insights titled The Future of Personalized Universal Assistant. Ladies and gentlemen, please welcome Dr. Ji.
Good morning, everyone. 早安，大家好。非常荣幸 I'm very happy to be back here in Taiwan again. This is my hometown. And it's interesting to look back on time over the last 30 years, ever since I was a little kid growing up here in Taiwan, and thinking about personal computing and where it's taken us to this point where we're all together here at TaiNext to get a little bit sense of what's going on in the AI revolution, or what I'm calling the intelligence revolution. Now, in thinking back on history, the first thing I want to talk about is something that became very surprising to me over the last 20 or 30 years, is something relating to ranking. Now, when I was a graduate student, going from that little kid growing up here in Taiwan and going to the United States to study, one of the most important classes that I took was a class called Information Retrieval. Now, it is a year-long class if you really wanted to be good at it. And I'm going to teach it to you in about 5 minutes, okay? So in the beginning, when I was growing up here in Taiwan, when my dad brought back a computer from a computer show that was called Computex back then, was that we had these little computers that was sitting on our desks. And it's pretty amazing to think that at this point, all of you own one of these that actually has more compute than that big machine that he brought home that I got to play on. And that started my own personal computing research career, if you will. And I started writing computer games and things like that. But looking at it, I remember thinking, oh my goodness, these computers can have so many instructions per second, and they work so fast, right? But in retrospect, actually, these computers have very little computational power. And information retrieval was a field that really kind of looked at the idea of that maybe we could do a lot of offline computation ahead of time in order to ensure that you have information at your fingertip. Now, if you were to attend these classes, one of the most important books, introductory books, if you really want to learn this field instead of in 5 minutes, is to go read this book. Now, this book has 3 authors. Christopher Manning, who is now a professor, well-known professor at Stanford University. Prabhakar Raghavan, who later on became the SVP for search at Google. And then the third one, Henrik Schutze, actually was an office mate of mine at Xerox PARC many years later after I took the class. And I remember looking at these people. They were giants in our field of looking at information retrieval. How did this work? How do search engines work? Now, I'm going to teach it to you 2 ideas in 1 slide. The first idea is something that everyone is very familiar with already. It's something called a reverse index. All of you used books where you flip to the back of the book to kind of look up things. That's the index, right? So we sort of say, let's say you want to understand Catherine the Great, right? That's an idea that you want to understand more about, and it will tell you which page it is on. Now, the beauty of this idea was that you could look up lots of concepts. And the beauty of this idea was that Google said, what if we did this for all the web pages out there in the world? Now, this turned out to be a very big task. But the beauty of it is that you could do it in an offline computational way. You can do it ahead of time. Jeff Dean, who's one of the revered engineers of our time and at Google, invented something called MapReduce in order to compute all the words in all the documents and all the web pages on their entire web. Okay. The second idea is something called a vector space model. What is it? Well, the idea was that if on one page it mentions the words Catherine the Great a lot of times, let's say 5 times, and then on another page it mentions the, let's say for example, the concept of the game Go, right? And it mentions it 10 times. Now, if you're looking up information about Catherine the Great, which page are you going to go to? Of course, the one that mentions Catherine the Great. You're not going to serve up the page on the computer game Go, for example. Now, the frequency of these concepts on these documents, let's say we were to tabulate all those frequencies and put them in a vector, and then we computed the angle between these vectors in order to understand their similarity. That was the idea behind vector space model. Now, I know it's roughly 9:30, early in the morning, and you feel like you just went to class, right? You were hoping that you have already left the university and you don't ever have to attend another lecture. But I'm a computer scientist. I'm a scientist. So I got to at least explain some basic concepts to you. Because why? Understanding these concepts matters in the current world. Why does it matter? I'll tell you the first mistake I made in graduate school. When I was in graduate school, I was taught these ideas by looking at these textbooks, right? And then my PhD advisor, John Riedel, came to me and said, what if we took these ideas, instead of documents, we have users. And instead of words, we look at items. And we're going to have people rate all these items, right? Let's say, for example, you like Star Wars, so you rate it a 5. And my brother likes computer game Go, so he rates it a 3 when the AlphaGo movie comes up, or something like that, right? So whatever the rating it is. And then we use the vector space model to build recommender systems. What do you think about that idea? I said, John, that's a terrible idea. Well, as many of you, this turned out to be a multi-billion-dollar business. How much of a multi-billion-dollar business are we talking about? Well, if you think about Google as a company, the 2 concepts that I just mentioned to you, the search and recommendations, it comprises most of our current business. If you think about it, almost all the apps on your phone, Google Play Store, Apple's App Store, or YouTube, it's all built on search and recommendation, even till this day. Despite all the conversation we've been having around AI, this is what's happening. Instagram, built on recommendation and search. More than 500 billion, probably close to $1 trillion of the entire internet industry is built on recommendation search. This is how important these concepts are, and they will remain very important going into the future. But of course, that was not the end of the story after 2004 when Google IPO'd. At some point in the next 10 years, we got a lot more compute. This was the first TPU cluster we ever put in production at Google. It was already liquid cooled during that period of time. So what I'm not going to force you to sit through is 10 more hours of lectures about how neural networks work and how we use it to build search and recommendation systems. But at Google, my team has improved search and recommendation systems using neural networks by more than 1,000 times and at very significant Google additional revenue. So the thing I wanted to emphasize is really the idea that in the beginning, between 1995 and 2015, there were only 3 ideas that really mattered. The first one was indexing, the second was vector space models, and the third was using neural networks to do these computations. When that happened, this enabled more than close to $1 trillion worth of software business. By the way, I have always felt that Taiwan really missed this opportunity from a software perspective. Right? There are many, many companies and industry partners in Southeast Asia and Pacific that all missed this opportunity, that only the United States really was driving very hard on these ideas for about 20 years. Now, I was already at Google and Google Brain by 2015. And at this point is when truly, in my opinion, a revolution happened. What is that revolution called? I would call it the sequential transduction revolution. How many of you think of yourself as an engineer? Any engineers in the audience? I see a few hands. I don't know whether they're really more about taking photos or not, but there is at least one hand over there. What does the word transduction mean? If you're not an engineer, you wouldn't even understand what I'm talking about. These 3 words, you have seen them in your dictionary probably. When combined together, you have no clue what it means, right? Maybe except for the 1 or 2 engineers that are in the audience. What the word transduction means is that it converts one energy form into another energy form. So let me explain. For example, you're experiencing sequential transduction right now. A microphone that I'm wearing right now converts sound energy into electrical pulses. And then that gets sent through a wireless microphone here, back over there. And then a speaker is actually another transductor. Okay? It transforms electrical signals into sound waves so that you can hear. The amazing thing is that if you don't think about it, your ear is also a sequential transductor because your ear has a membrane. It vibrates when you hear what I'm saying through the speakers, and it vibrates against a little bone, and that bone transmits neural signals into your brain. And that's how you understand what I'm saying. So if you think about how amazing this communication that's happening right now, admittedly is a little bit overly one way right now, is that all these transducers have to work. The microphone has to work, the speaker has to work, your ears have to work, and then you have to receive these signals in your head in order for you to understand semantically what I'm trying to say to you. That is the beauty of sequential transduction. I'm saying these words one by one, and you're understanding these words one by one. And that was the realization in 2014 at Google. The idea that maybe we can mimic these sequential transduction processes that are happening naturally in our brain in order for us to essentially communicate to neural networks, if you want to think about it that way, okay? So by that point, what can we do? We could do things like put in pixels and get, oh, that's a lion. We can put in audio and it'll say, oh, the audio means how cold is it outside. We can do machine translation. You can put in text that says, hello, how are you? And it'll say, bonjour, comment allez-vous? You can put in images and ask it to describe what was in the image, and it'll say a blue and yellow train traveling down the tracks. Now, it is the idea that each one of these tokens are being transmitted into the model one at a time, and they're coming out one at a time. That's why we call it generative AI. A lot of people don't even know that. Why do we call it generative AI? That's the reason. It turns out that there's a beauty to generative AI. What's the beauty? If you're a scientist, you're always looking for beauty, right? And when I say beauty, I'm not just talking about Lin Zilin. Right? We're looking at the beauty of the order of how things work. And it turns out that when you build these sequential transduction machines, what can happen is that you can aggregate all these functions into a single model. That was the mind-blowing moment. It turns out that you can put in question and answering, summarization, all the translations between 40, 80, 100 languages, all in a single model. You want a Japanese to English translation? One model. English to German? One model. German to French? One model. German to Vietnamese? One model. How incredible is that? If you had realized that by 2015 this was possible in neural networks, you should have bought more Google and NVIDIA stock. Did you realize that if you put in $1,000 in January 1st of 2015 in NVIDIA, it would have risen 460 times? That means it's worth half a million dollars. Right? So understanding the past and understanding what's happening now allows you to predict into the future. This is what we're here to do. I hope you woke up this morning thinking, I need to learn more so that I can predict the future better. That's what we're trying to do here. Now, I do want to commit one more idea into your head before I show you something so that you can start predicting the future, which was in 2021 at Google, we asked the question, why are these models still really dumb? Yeah, you can do machine translation, but it's not thinking. It's doing transliteration of a certain kind, but a lot of times it doesn't seem to really understand. What do we mean by understanding? Well, machine learning for a very long time was about input and output. We started thinking maybe we can teach machines the same way we teach our kids by inserting explanations in the middle of these examples. So how would that work? So for example, if we give it a math problem and we use the input-output approach, we would have said, oh, 5 plus 6 is 11, and therefore the answer is 11, right? So you just write down 11 without explaining how you got to that result. But we have all seen our kids struggle with these math problems when they were young, in elementary school. But if we show them, sit down and be patient. Now, that's the hard part. We got to be patient and explain things to our kids and say, oh, well, you see how we solved this problem? It was 5 plus 6, that's why it was 11. So if you have this other problem with 23 apples, you use 20 apples, that's 3 apples left, and you bought 6 more, that's 9. It's not 27, it's 9, right? Then all of a sudden, the model starts to, oh, I need to follow these tokens or solve problem-solving templates to solve problems. That was the beginning of reasoning for these models. It was absolutely incredible at the time when we discovered that you could get a machine, sequential transduction machine, to follow programs, essentially, instruction following, if you will, to solve greater problems. In fact, they improved reasoning capabilities at the time, even using GPT, by 2x using this approach. This is called chain of thought. So in retrospect, now looking back, merely about 3 or 4 years ago, using chain of thought along with sequential transduction was the beginning of large-scale reasoning machines. Now, to this day, I feel really bad. Why? Because we started calling them large language models, even at Google. But in my personal opinion, we should have started calling it large reasoning machines by that point. Because the whole point about AGI is not that it can speak our language. It is that it can reason the way that we reason as humans. That's the beginning of mimicking human intelligence. So it turns out there were only 3 ideas between 2015 and 2025 that really mattered. And there were 3. Sequential transduction, chain of thought, and post-training. Now, I always have one more so that you'll invite me back, which is that post-training, I have no time to explain it to you. So I taught you 2 ideas. not all 6, all right? Not all 3 here. So 6 ideas, there were 2 of them that were very complicated that I don't have time for. However, even with those ideas now you have in your head, I think you can start to predict the future. Now, I think this is as good as what Jensen Huang did, I think it was last night. He apparently signed his name on a lot of bills and gave it out. I don't know how many of you saw the social media on that. I'm kind of doing the same thing with this, because what I'm trying to do is to get you the ability to predict the future. Okay, so I want to show you what the future might look like. Now, I don't have a lot of time left, about 5 minutes or so. So I want to show you a series of little clips from a video that you can find on YouTube, something that my team, my research team is working on. I'm going to ask you the following question. What if the order and the structure of the overall internet market changes from recommendation and search into something else? What are you going to do then? Where are you going to put your money, for example? How are you going to invest your time? Let me show you one example. Can we have the sound, please? Uh-oh. No sound. When you started the presentation, you needed to make sure that it says audio. Okay, now I'm going to have to narrate what's happening in the film. That's okay. So this gentleman is in London exploring the world, right, in London. And he asked the machine, oh, I got an email with the door code. Can you please read it back to me? And so he gets in. He needs to learn how to use a foreign washing machine. He points the camera at the washing machine and says, can you teach me how to do it? And then he's looking at the list and he's sort of saying, hey, these are the places I want to visit in London. Which one of these would you recommend? Now, in the next clip, oh, he's going backwards. No, that's all right. Let me go back. I believe it would be, sorry about this problem. Let's go one more. Okay, one more. Go back, go back. Okay, well, in the interest of time, let's keep going. Here's an example where he's doing this using this pair of glasses. This is a prototype glasses with a display on it. So you could see that as he puts it on, he hits a button on the side, and he asks for the weather currently in London. I don't know how many of you have been in London, but it's almost always raining. So this example is actually a little bit off because it's actually not raining in London there in the example. So what you can do now is that you can use these multimodality models and actually put them on glasses. Now, they're not actually running on device. And we can have a whole conversation just around whether these models should run on device or not. It's a very big topic for the period that we're involved in. Okay, so let's keep going. In the last clip here, let's see if we can get it to play. Oh, now there's sound.
What was the door code again?
The door code you saved previously is 1170.
Oh, thanks. That works.
So what we saw in these videos is the idea that there is a universal agent that's following you along.
With the latest test build of Project Astra, and we're going to leave the office to test it around London. I've got this email with apartment info. Can you tell me the door code and remember it?
I'll remember the door code for you. It is 1170. To unlock it, enter the code and then press the unlock button.
Based on these symbols, how should I wash this?
The tag shows to machine wash at 30 degrees Celsius. Avoid bleach and tumble drying. Iron on low and dry cleanable.
Then what settings should I use on this machine?
Based on the laundry instructions of 30 degrees Celsius, select the 30 setting under Easy Care on the dial.
I've got this list of recommendations. Can you tell me a bit about some of them?
I can search for these places for you. Cold Drops Yard is a shopping destination with unique industrial design. Luminary Bakery is a social enterprise bakery. And Tate Modern is a modern and contemporary art museum.
Now we're going to try Project Astra out on the street.
Okay, so that's probably enough for you to get a sense of what was going on in this video. I hope you get an opportunity to check it out. But that was not a marketing video. It's running on my phone, right? There's no reason that this would not be running on your phone in the next little while. I won't say when, but it should happen very, very soon. So if you start thinking about how this is going to change, how we interact with computers, right? From the days I started out with, where we talked about using search and recommendation and information retrieval, and all we are trying to do is look up some concept at the back of a book. That was 30 years ago. All the ways fast forward to this day, where you just point your camera at the list and say, which one of these places should I go if I have a young kid? And the model will reason with you and give you an answer. How incredible is that progress in 30 years? And now that is enabled by agentic AI. And we're hard at work on these research projects and ideas at Google Deepmind. So with that, even with a little bit of the problem in between, thank you very much. I appreciate your attention.
感谢季怀新博士精彩的分享。下一个精